because we just got talking, and Tristan's been doing some really interesting stuff with Amazon's web services and is in their beta program. And yeah, we're going to talk about it tonight. Won't say any more.
No. Okay, my setup is not entirely I'll finish it right before I do the actual demonstration. I'm Tristan. That's probably all you need to know right now. I'm going to give you a quick rundown of what I'm going to talk about. First thing, flyover in introduction of the services. I'm not here to sell you anything or give you on the opposite extreme highly technical information. I'm just here to make you aware of what's available. Then I'm going to throw some ideas on how you could actually use the services, then hopefully go a demonstration. And then we're going to follow up with the more or less traditional Q&A. There's only one goal, it's to make you think. Again, I'm not here to sell you anything, I'm not here to pick myself. It's just that it's pretty interesting technologies, and it's a pretty interesting package, and the idea is just to get people talking. First thing I want to get out of the way is why Amazon? Well, they've been running the type of infrastructure we're probably all interested in, except they've been running it since 1994 at a seriously scary scale. And one thing that most people don't know or don't realize is the fact that they know web services better than most for one simple reason, which is that they've actually based their entire business on a web service, which is the affiliate web service. Back when no one had actually heard of doing affiliate marketing. And they were obviously using them before anyone had thought of calling them web services. So the talk is actually Amazon-centric, but the solutions are completely generic, so you can feel free to just pick some ideas, re-implement them, do whatever you want with them. So let's move on to the actual services. I'm going to talk about 3 services, there's in fact 7. The ones I'm not going to talk about, I'm going to get them out of the way right now. That's the Mechanical Turk, aka the Virtual Sweatshop, not very popular. The Historical Pricing Tool, which is very, very interesting if you're selling stuff online. They give you 3 years worth of sales information, which you can run queries against. Very cool stuff. Alexa's Web Search, which allows you to build entire search engines without any infrastructure. And obviously the affiliate service. Thanks. So let's move on to S3. S3 stands for the Simple Storage Service. You've probably already read about it. It's been talked about quite a lot, and by discussing stuff with a few people, it turns out that it's being discussed several times a week in the blogosphere, and most people are still seeing it as simply backup storage, but it's in fact much, much cooler than that. Essentially, it's pay-as-you-go storage. You write, read, delete unlimited objects into unlimited buckets. Your objects can range from 1 byte to 5 gigabytes. You manage them using an API through REST and SOAP. Your objects can then get served using HTTP and BitTorrent. I personally have no use whatsoever for BitTorrent, but it's apparently a somewhat popular feature with some people. For example, if you do podcasting, you store to S3 and you get automated BitTorrent distribution without lifting anything in. Your object can be kept private or made public. You manage that using ACLs. And you can actually get friendly or friendly-ish URLs by using vhosts. So for example, if one of your domains is example.com, you can have static-assets.example.com / the name of your file, and you CNAME that subdomain to the Amazon backend, and it looks exactly like if you were actually hosting the files on your side. The really defining feature of S3 is that it's seriously dirt cheap. It amounts to 15 cents per gig that you store per month, then 10 cents per gig that you move to S3, then 18 cents per gig that you fetch from S3. The price is digressive. It goes down to, if I remember well, 0.13 cents. And then you pay what I call peanuts per hit. It's not free, but it's basically pretty much nothing. To make things even more complicated, the transfer fee is waived to and from EC2, which we're going to see in a moment. If you remember one thing of that previous slide, calculating the fee is pretty complex, but completely pointless. The usual reaction when you get your first bill is to just laugh it off. You just look at it and you're like, what? I've been using a service like S3 and it's only cost me something like 53 cents for the month. And yeah, calculating it is a complete waste of the time.
Not for everyone.
Not for everyone, but when you start, it's a complete waste of your time. When you ramp it up, obviously, it gets interesting to calculate it, like we see on that one. On very, very high volume stuff, stuff that probably no one in that room actually does.
These guys do.
Do you?
I don't know.
Or how many terabytes of data do you store?
Stefan?
Not that many terabytes, but we transfer a lot.
Okay.
Yeah.
These figures are actually from people like SmugMug and companies like that which do photo hosting. They run some calculations, and they estimate that they save between 50 and 90% when you take into account the disks, the servers, the colocation, the staff that you need in order to go and replace disks and stuff like that. So I'm not going to do the calculations for you, but that's the figure I got from people who I tend to believe. And on low volume, the other extreme, Jeremy Zabovny actually did a funny post on the fact that he was looking whether S3 was interesting, and the conclusion he came up with was that it was much cheaper than keeping his old PC powered, which he uses as a file server. So just based on the electricity. So that's done with S3. Let's move on to SQS, the simple queue service.
Do you want to break the pizza?
There isn't much noise about it, mostly because it looks rather uninteresting, and in my view, people simply don't get it. Essentially, it's pay-as-you-go messaging. You can send unlimited messages into unlimited queues. Your messages get stored for up to 15 days. Using REST, you can have a payload of up to 8 kilobytes. Using SOAP, you push to 256. The way it works, you have a producer which sends a message and then forgets it. You can actually keep track, but that's usually not the idea. If you're looking into ways of keeping track, you're probably trying to use SQS for the wrong reasons. So go back to the drawing board and
Do you send a message via HTTP or you use a library?
You have to use libraries, but it's so simple that you can pretty much write your own. The only thing which is a bit tricky is the authentication. So you have to steal someone else's authentication to see how they read
But
it.
when I send a message and forget it, I get an acknowledgement from the service that the message has been received.
That the message has reached the cloud, yes.
Okay.
Yeah. But there's no acknowledgement that someone has actually activated the message. It's just latched into the queue that you know that it's reached the queue. Then on the other side, you've got a consumer, which holds a queue asking for new messages To keep it simple, I'm going to stick to the singular form. So you ask for one message right now. You get the message. That message gets locked. You act on the payload, and then you delete the message.
You have to delete it.
Yes. I mentioned logs, and it's called the simple queue service. So usually when you mention log, you can't really call it simple. So I'm going to have to go through probably the most complicated slide in that presentation. If a message is read, but not deleted, SQS thinks that something went wrong somewhere, and that's a design choice you have to agree with. And realizes that when you log for 5 minutes, you actually end up running jobs twice. You can increase to 10 or decrease to whatever. That's really complex, and you probably don't want to think too hard about it until you've started playing with it. Yeah.
The message pops again into the queue.
Yeah.
Does it get?
It's a completely distributed system. They don't guarantee that things will be in the right order. Yeah.
Can you find out that someone else writes the message before and obviously fake?
Yep. Or at least, and that's one of the very, very important things about the Amazon Web Services. They don't provide that information for you, but if you want to get more clever, you can use the different services as building blocks and build a lot of intelligence. They go for very, very simple services, which you then use as building blocks for more clever stuff. Any more questions on SQS?
Yeah. That's an example scenario.
There's going to be one at the demonstration. So let's move on to EC2, the Elastic Compute Cloud. Don't get hung up on the name, but it's interesting to remember because it actually tells you a lot. Essentially pay-as-you-go CPU, so we've seen storage, we've seen messaging, we are now at CPU. Again, in Amazon's tradition, it's dirt cheap, runs you 10 cents per instance per hour. To say we're calculating, that's $2.4 per day, or roughly $72 per month if you were to keep your instances up and running 24/7 for a month. And I don't think you should be using Amazon EC2 that way, but I'll get onto that later. Essentially, it's Linux-based using Zen. The images are based on Fedora Core or Debian, so it's pretty easy to get started. There are plenty of base images available. Pretty much the way the VMware community works, you basically get people submitting very cool images, and you can simply run them, see what you like, and you get root access so you install anything you want. It feels pretty much like a VPS, except when it comes to the specs. For 10 cents per instance per hour, you get a pretty beefy CPU, a lot of RAM, pretty decent hard drive. Gets interesting or complicated when it comes to the network. You get 250 megabits per second. They say it's burstable to 1 gigabit per second. Yeah, we'll have to trust them on that. Essentially, your instance has one interface, which has a private IP address. That private IP address is network address translated to the outside world or not. So when you boot your instances, you can say, I want them to be 100% private, in which case they are not visible from the outside world, or you want them to be public and they get a public IP address for forwarding. When you boot your instances, you boot them within a predefined external firewall policy. In my case, I've kept things very simple. I have a default firewall policy which says port 80, port 22 are open, and I boot all my instances in that default policy. The interesting thing about the policy is that you name your policies, and then each and every instance which shares a policy gets put in a VLAN, and can actually see all the other machines which are in that policy. I've told you the networking part was a bit complicated. What makes EC2 unique is that there's no setup cost, no commitment, no delay beyond the boot process. To give you an idea, from the moment you run the command to start your instances to the moment where your first machine comes up, the first time you do it, it's probably in the region of 4 minutes. Next time, it's probably in the region of 1 minute. And you can start 1 to 20 instances in just one command and stop them just as easily. If you do need more images or more instances, you are running with Amazon. I've read some stuff about some people who I trust having run up to 400 instances in parallel, and I've read some blogs from people who I do not trust as much who've mentioned thousands. So I don't know where the maximum really is, but I know for a fact that some people have run 400 instances in parallel. There's a major gotcha with EC2. Your instances are actually ephemeral, which means they don't stick around. You can't really reboot them. When you start an instance, you get a fresh disk, completely fresh, with your image freshly installed on it. When you stop your instance, it gets completely wiped clean as well. You need to keep that in mind, or it gets extremely painful. Okay? That's where S3 actually makes a comeback, because S3, as we said, is the storage service. Okay, to give you a really cheap analogy, you have to think of it as a cheap hotel room. It's got everything you expect from a hotel room. Don't expect to feel at home. Okay? If you leave your valuables behind, they're gone. And that's because between guests, they clean the room back to their standard room. Well, that was a very short-lived analogy. Basically, forget about it. You can customize your room, but you need to actually go through a design process and think about it. Then you have to really decide which packages you want and so on. Then you describe that to the hotel manager in AWS terms. You make an image, you agree on a name, you put it onto S3, and then when you book a room, you don't ask for a hotel room, you ask for n rooms configured as your hotel room. Okay? So using them for VPS-like use is possible, but if you ask me, it's rather dumb. Okay? If anyone has been using them as VPSs, talk to me later. Okay, yeah, it's the elastic compute cloud. It's not cheap VPSs on demand, otherwise they wouldn't be elastic, and yeah, I'll let you imagine the rest. Okay, I'm done with the sales pitch. I'm gonna touch on what I think they got right in terms of marketing. Obviously the price. It's very, very simple to get started. They provide you with very simple building blocks, which actually take you roughly 80% of the way. In that 80%, you have very few imposed design choices. The ones they impose on you, for example, when it comes to SQS, a really tough one. They're going to say, that's the way that's what you get, that's it. But it's actually very, very good for you to build your own tools, because you're not stuck in something someone on the other side of the world has actually decided that you will need. They give you more or less the Lego bricks that you need in order to be really creative. And you can come up with very, very interesting schemes based on these free tools. That, I think, is actually a lesson in API design. They've built really basic, rock-solid services on an open API. They provide you with what I call broken leaves, which are they're functional, but they really cause an itch to make them better. You really want to make them better, because you need them to solve your problems. Then they listen, learn, and make things better all the time, but only when power users have real problems. They don't want to please the blogosphere. It's actually one thing that's quite important when you look at the blog posts about Amazon. They get bashed on all the stupid stuff that they don't want to support, and you get armchair strategists who actually come up saying that Amazon is doomed unless they support OpenID or unless they support rsync and stuff like that. And Amazon will actually not get in the discussion. They're just not interested. They'll focus on the power users, the guy who actually come up with creative solutions. And there is an entire ecosystem building on top of that service, so I guess it works. So if you're into building APIs, I think that's a good lesson to learn. Okay, done with the marketing. I'm going to talk about the tech stuff. That's basically the part where I throw ideas at you, and you can fight back or basically talk about things you think you apply better or whatever. You are more than welcome to turn it into a complete free-for-all. Right now it's US based, so you do have some latency. From my place it's roughly 120 milliseconds, which makes it not exactly suitable for production infrastructure when you target Swiss servers. Well, that's unless you're dealing with very, very painful tasks, or when you want to only rely on it for a limited time. For example, when you're taking your entire infrastructure because you're rebuilding it, or simply doing maintenance, or moving to another data center.
But how much can a download sustainable? After waiting 120 milliseconds, what's then sustainable download?
You'd have to hit the Amazon website and check it. It's pretty good, but I've not measured it.
So actually it's no competition to these other content delivery services. So for example, for us, for Tilate, currently it wouldn't make sense to host all our images there, I guess. Because
I'm going to talk about it later.
Thinking about using this service. Looks really... but this latency...
Okay, let's jump forward. One of the things you can do with S3, if you're looking for ways to get started without investing too much money or using your brain too much, what you do is you install a script proxy right now in your data center just to see how it works, but you can actually distribute them in other data centers. You configure it as a web accelerator, and you tell it to never touch the disk, so it runs only in RAM. Then you configure a script to forward all your cache misses back to S3. You point all your static assets on your website to Squid instead of your proper servers, and you leave the cache management to Squid. So you don't do any kind of cleverness, and all you do then is all the content that's static, you upload it to S3, or your scripts will actually take the content from your users and push it to S3, which leaves you with only the dynamic content you have to sell locally.
Sounds good.
Yeah. That was pretty consulting. Yeah, so you have to work around the latency right now. So it's not suitable for everything, but you can find some pretty damn cool uses. Seeing how Amazon evolved over time, they were originally a US company. Now they have data centers all over the place, and they are pretty much a global company. It's not completely out of the question to see European-based data centers coming up in the future, so the latency issue might completely disappear over time. The way I use them, for example, is mainly for data crunching. One of the things with data crunching is the fact that you have to, well, you often have to have a lot of RAM. Using Amazon, I can get 35 gigs of RAM for just a few hours. If you were trying to build some local infrastructure, giving you access to that kind of RAM, you'd be looking at serious money. And you'd be powering these servers over time, when I'm just shutting down my servers when I don't need them, and my bill is probably in the region of something like $15. When used, is probably $15 per day, if you're really lucky, or per day per server. Other thing, when you do data crunching, the disk I/O is the complete killer. With EC2, you get a pretty decent disk, dedicated disk I/O, multiply that by 20.
Can you mount S3 as a file system?
You can, but I'll tell you that it's a bad idea. But
so you have to write your own storage?
No, well, I mentioned the fact that there's an entire ecosystem building itself on top of the Amazon Web Services. You can get low-level device drivers, which will actually talk to S3. There's a guy basically making a living and who's actually turned that simple idea into an entire company, who sells one device driver for S3. I've heard it's pretty cool, but I personally don't use it. I'd rather keep things extremely simple and use the limitations of Amazon as simply as a constraint to come with much simpler designs. Another pretty cool use is to reduce your lab costs. So when you have a development team and so on, you usually have to have production servers, development servers, and so on. With EC2, when you want to test entirely new ideas, you don't have to completely rig your development environment and then worry about reinstalling everything, reconfiguring everything. You simply define a group of servers that you want in the right policy groups, and you boot up your entire lab when you need it. If two guys want to access the lab to do different things at the same time, which in real life is an absolute nightmare, you just boot two, and when they're done, you shut them down. Needless to say, that's a really good way to design and properly test the scaling strategies. Because if you were to, on your local hardware, check whether you can make a small change and see if you can pull so many gigs of data per day or so many megs per second, it's probably a very tough one to do reliably on your local network. Another really cool side effect of using them as a lab is when you've duplicated your infrastructure or the important parts of your infrastructure, you've actually got pretty much disaster recovery ready to roll. Click of a button, change the DNS point to S3, and you can relax. You've basically dealt with one of the toughest problems in computing or in actually running servers that could come to you. So how do you get started? If you do want to get started, please listen up. You need to apply to S3 and then start using S3. Okay? Then and only then you apply for S3. I have a theory that they're using that as a filter for people who don't actually want to read the docs, because they tell you that you have to do it in that order, and if you don't do it, you're probably going to end up waiting for months because they've just deleted your application. Do it in that order, and it's going to probably take a few weeks, but then you're going to get approved. And yeah, read the docs while you're waiting. It's always interesting. And my advice is start simple and try to keep it simple all the time. Okay, I'm going to do a pause right now.
Aber wir haben jetzt bestimmte Quantität, dann kommt die andere machen, aber da ist die Steuerung. Ja, die muss die kommt die andere, Du kannst es gleich so als aha, und nachher, momentan ist so, dass du Disks von der kannst du Sachen aufladen und dann hast du das im Connector zu alles versetzen und das S3 unten anhängen und dann kannst du da aufschreiben. Und dann merkst du, Latency
Da könntest du natürlich auf jeden Fall.
Das ist vor allem, du kannst das Totsystem runterfahren. Ganz null.
Also, ich meine, das Straße in der Mitte Nein, wir haben Social Interaction.
Okay, I'm pretty much ready to start, at least to start giving you some background information about the demo you're going to see. And it's pretty tough to actually show distributed stuff, but you're going to have to use your imagination. Basically, it's only a small part from a much bigger picture. I have a workflow which has something like 7 or 8 major tasks, and that's one of the tasks which I'm going to show you today. To help you understand why I'm actually doing it that way, I get access to a lot of what I call dirty feeds, which are product feeds coming from a variety of sources, including people who have absolutely no clue about XML, yet produce XML, or produce CSV or TSV or whatever SV they could think of right now. It's broken in extremely creative ways, which change all the time. And obviously, in order to be able to do anything with that junk, I need to be able to turn the data into a common format, which I can later end up using. So I've defined a common schema for all the crap that I get, and I turn every single feed into an SQLite DB, so that I can actually run some queries onto my SQLite DBs and basically do some useful stuff with them. These SQLite DBs end up being of variable sizes. Some are a bit too big for comfort. And all in all, I've got several gigs of feeds in different languages. And my challenge is to index all that stuff into Lucene, so that I can make the retrieval pretty fast and do all sorts of cool stuff with Lucene. I've actually been working on that project for the best part of the last 2 years. So over time, I've actually come with some really hard requirements, stuff that I will not even negotiate. That's the fact that I want to be able to trace my indexing problems. So if I notice that something is broken, I want to be able to immediately know why it's broken, where it's broken, and go fix it. I don't want to look at a monolith. I want to look at very, very simple processes, or at a pipeline of very simple processes, and I want to know exactly what is broken. I obviously want to be able to do partial reindexing. For example, when a feed gets broken in a really novel, very creative way, I need to go and fix it, or go and disable it if it's not something I can fix. after making really small tweaks, or obviously when a feed gets updated, I don't want to have to run the whole thing. I used to run the whole thing on my laptop, and you can imagine having a pretty decent dual processor or dual core MacBook Pro running with both fans at 5,000 RPMs for something like 48 hours. Nasty. You don't want to do that. On the other side, I don't want it to burn a hole in my wallet either. So, some software requirements. I don't like being tied into specific technologies. Mainly, I tend to find myself more productive in Ruby, but I'm pretty Java friendly when it comes to specific teams. For example, Lucene. I don't want to put down any money up front. So actually building myself a custom cluster is completely out of the question. I would like to spend as little time as possible learning new technologies. And because of the way I work, from time to time, I actually quite enjoy the fact that I can freeze the entire thing and work on other things without paying for a completely dedicated cluster which runs me into tens of thousands of pounds. So the solution I've come up with, at least for that particular problem which I'm going to show you, is that I store my SQLite DBs on S3. Then I use an SQS queue into which I send pointers to the DB file that I want to split. I have a splitter process, or a pool of splitters, and in that pool I get one splitter which receives the message, fetches the DB, generates XML chunks with 500 entries each, stores them on S3, then sends a message to another queue where there's a pool of indexes reading. An indexer fetches the chunks, creates and populates a Lucene index, and stores the index on S3. Yeah, ignore that one because I'm actually running it right there. So I'm going to give you a run through on one feed just so you can see what it does. So there I've sent a message with a pointer to a file in my SQLDB bucket. Hopefully, if things have been queued properly, we should see a chunk anytime now. Yeah. It's going to get picked up, or it's been split. It's going to get indexed. Then we're going to see an index, and then we're going to see some solo stats anytime. It's the refreshing which kind of sucks. Yeah. So that's it. Okay.
So that's a single task.
That's one atomic operation which I'm doing because if I had done what I'm just about to do right now, which is to queue a whole bunch of feeds, it would make no sense whatsoever. So yeah, there I'm actually unqueuing feeds to be processed, and you should see them popping up like popcorn. I've got 5 instances running at the moment, and it's going to be pretty hard to track, so I'm going to leave it running for 2 minutes. If you have questions about the process, let's go. Yeah.
Potentially stupid question, but
go ahead.
The scene index, isn't that a thing that has to be done on one single machine? Can an index be split?
Yes, of course.
Okay, I don't know the scene, so it is a stupid question. That's why you
It's not a stupid question, actually. It's not obvious, but yes, you can do it. So, yeah, we're probably all going to get incredibly bored. Basically, it works, it runs a whole lot of stuff in
these
Power.
chunks of this XML with 500 items in it, and you then mark in the DB what items you have extracted. Because you said you made, the XML chunks are maximum 500 items.
Yeah, that's a completely arbitrary limit. Which
Okay, but then you, in the DB, you mark what items you have extracted, and then you have to write back the DB because you may be attacking DB multiple times.
Yeah, that doesn't matter.
Okay, you just queue them. You just roll them up. You run one DB job, and after 500 you.
No, the way I do it is I have one DB which I'm going to split into chunks which get named in a format which is the name of the feed underscore dump underscore the starting offset in that DB.
Let's suppose the DB has like 1 million of records in it. So you take the first 500, whatever order, and then you mark them as deleted in the DB.
Yeah, I don't delete them. I keep them around.
Yes, because you have to mark which you have already taken.
My DB actually goes more or less atomically into the system. Because of the way I'm doing it, if there's a failure anywhere, I consider that the entire job is completely useless. And because I keep stuff separated, I can have something like 150 feeds, see that feed 63 is not complete, for example the number of products doesn't match, then I can actually go back to the indexing results, or the Lucene index, or the stats, and see where the problem actually happened. But I don't have to keep track of everything. I consider one DB as being a complete job. So either it gets indexed, or there's a problem, but at least I know about the problem.
I guess you know SQLite as well, and it's like file-based database.
Yeah, it's very nice.
Yeah, you don't normally put tons of stuff in there, I guess.
Did I get this right? So you actually run a lot of index. You split the whole thing into a lot of separate parts that you could actually index them on separate servers, right? So you don't have just one index, but you have multiple indexes.
I have one index per field, and then once I'm done indexing the specific fields.
But that is parallel in several places, right?
It's parallel in several instances which run within the cloud, and they store the data back to S3.
Yeah. So I'm another of those guys who don't know Lucene, for the same reason as Urban. And so maybe you could say some 2 or 3 words on how you put together these separate indexes at the end, so that you can make queries. What you have to do to put those parts together?
You call the function merged indexes in the Lucene.
So that's not something that's very CPU intensive, or is it?
Not really.
Oh, I see.
Yeah.
Okay.
Once the indexes are actually done, it's pretty simple. It reads them in parallel, or probably you don't have something like 20,000 indexes. It's not that tough.
Okay, cool.
And the indexes are not terabytes of data. It's because I don't store, I only index. They're actually pretty small.
Okay.
So
not the smallest.
Okay. Now that you've seen it, it's possibly the wrong choice of words. Okay. But I think it actually maps a DB to XML chunks, and then it reduces them to a Lucene index. If you catch my very subtle subliminal message, okay? Okay? Okay. Okay, I'm just going to finish with some closing words because, yeah, you've seen the demo. I've talked about the whole thing and so on. If you ask me, it's seriously one of the things lately which has been completely changing the landscape. If you take the services I've told you about separately, it's completely dumb. It doesn't do anything revolutionary. But together, especially at that price, from someone who's as serious as Amazon, they actually open up a ton of possibilities. With an extremely low barrier of entry, both financial, but also technical. I'm not an expert in distributed computing, at all. I had never touched distributed computing before playing with Amazon, and these days I actually do pretty much anything I touch, I do it that way, because I've started considering distributing tasks around exactly like threading in a normal program. You get your head around it, and you see the world very differently. One thing, just don't ignore it. There's probably two types of people in the room right now. There's the people who are thinking it's just great, it's gonna allow me to start my new company for a fraction of the money and come and kick the big boys' asses. And there are the bigger guys who are thinking, well, we've actually built ourselves an entire infrastructure which we would have loved to do on something similar to S3. Yeah, tough. Yeah, don't ignore it, because it actually gives your potential competitors, including people in the room, a very, very serious edge. There's no commitment, it's flexible by design, so the cost of failure is completely minimal, which takes away a lot of mental bias when it comes to starting a new company. Because with running your startup on an infrastructure like that, you don't actually have to invest a lot of money. You get access to really hardcore technologies for virtually no investment. And the scary thing is that the ever-evasive idea of building your entire business on AdSense money, that's actually starting to work for some people. So they don't even need external investment anymore. They simply run a service for something like $20 a month before they actually run into EC2. Then they ramp it up to something like $100 per month. And then when they get bought by Google, they were probably running a bill for something like $5,000 per month. Scary stuff. And I'm going to conclude on the fact that, you know, the proverbial 3 geeks out of Starbucks, these days they can actually start something pretty damn big. So, I don't know if you still have questions.
What if I don't trust Amazon?
Yeah, that's why.
Then you know what? Build your own. It's not a problem. Build your own system based on these ideas.
Well, we formulated the question. What are the privacy policy and what is privacy policy Amazon for data stored in S3?
In S3, I'm going to give you the Amazon marketing speech.
In the US.
Yeah, that's a point.
The thing is, the way you connect to the API is through really serious-looking keys, and these keys are actually used to. They're all coming out of cryptographically strong stuff, supposedly, and you get a huge number which you then have to use in every single request to sign everything and so on. And what they say is that they encrypt your data into chunks, which they distribute around the cloud, and only you with that key can actually extract the data. That's marketing speech. If you don't trust them, re-encrypt your data. It's as simple as that.
In the conditions, they allow themselves to reduce the number of machines in the lights of cloud during Christmas because they use this calculated power. Has this happened to you?
I don't know. I've been running at Christmas.
But I thought this was what the original idea. They needed this infrastructure around Christmas, and they didn't need it the rest of the year. Not the storage part, but the CPU part.
It's actually a strong possibility that they do need that infrastructure because from stuff I've seen from Amazon, what you see of Amazon.com, Amazon.de, and so on actually comes straight from that infrastructure. They've based their entire business on EC2, S3, and SQS without even calling them services. They've actually pretty much extracted the services from their own needs. So they've been running that stuff for years, and yes, they will probably maybe not shut you down, But the way it works is when you request instances, you say, I want a certain number, and the minimum I'm going to be satisfied with is another certain number. So for example, right now I've started 5 instances, and I said, give me 5, or don't give them to me at all. If you want to have something like 100 machines, you're probably going to say, give me 100, but I'll be happy with 70. And over Christmas, they'll probably tend to give you 70 rather than 100. Privacy, anything else?
Backups usually contains, private data, mails, for example.
Encrypt them.
Yeah.
Split them in chunks, encrypt them.
Yeah.
It shouldn't be a problem. It's not much more of a problem than me coming to your house and stealing your machine right now.
S3 is not a problem trust-wise, but EC2 is. Because if you're web-facing and you're serving stuff from there, you have to decrypt it on those machines. And whoever has access to those machines can potentially, if he's malicious, read all your company secrets.
But if you do serve data which is considered extremely sensitive, you probably wouldn't want to use EC2.
For example, we never serve the phone book because it's so secret.
The phone book software would have to be on there too. That very good phone book software.
It's really simple tools. You can do a lot of stuff with it. Obviously, it's not gonna solve every single problem in the world, but it's actually a very, very valuable tool set. So, yeah, it doesn't solve everything, but my message is don't ignore it, because it's actually seriously changing a lot of stuff. There's entire companies starting up based entirely on providing extra services on top of EC2, S3, and so on.
I have a question. It sounds quite scary if whole companies rely on that thing, because I mean, what is their commitment to keep it running or not to change the conditions?
What is Amazon's commitment to being able to carry on serving their data on that same infrastructure?
Yeah, they themselves rely on it. Okay, but they can find out it's not really making money, so let's just shut it down for the
Come on, they just reduce the price.
It's not so bad.
Yeah.
Just reduce their prices now. So
yeah.
I think they're making money.
They are making money, and more importantly, let's talk about marketing for a minute. They're actually putting themselves back on the map when it comes to techies, because all of us, we forward pretty much for hundreds and hundreds of francs all the time from Amazon, and we've forgotten that they are a cool tech company. They're just people who just put books in a box, send them through the post, They've actually put themselves back on the map. So when you think Amazon, you start thinking, well, pretty cool stuff, and
I want to work there.
Yeah. Maybe not I want to work there, but at least next time you want to buy a tech book, well, you're going to hit Amazon twice as fast as you were doing 3 months ago.
Do you have any experience with grid computing, which is supposed to be the whole thing from the big companies like Sun or IBM?
Sun has actually been talking about grid computing for an awfully long time. If they had made it available at that price, I would have probably been using grid computing.
In containers. I think Sun's grid computing chips in containers.
Yeah, and if you want to offer one for Christmas, I'm more than happy. But yeah, it's a matter of money. They're probably targeting the technologies as to very different people. For example, if you have an established company and you want a lot of power to do your own internal stuff with extremely high levels of security, sure, go ahead, buy your infrastructure or rent Sun servers and so on. But the entry point is going to be very, very different. Because I doubt I can go and talk to Sun and get them to install stuff in a data center for me, and I'm going to pay 53 cents while I'm just playing with it to see if it works and then decide that it doesn't work for me. It's different markets.
I thought it was fully automated as well. I don't know. That's why I asked.
Probably. I'm not the kind of guy who can afford to play with that kind of toys. I stick with my Amazon provided toys. Yeah. But the one thing that's actually quite interesting, and thanks for throwing me on that sideline. There's probably going to be, in something like a year, a lot of people on the job market who are going to be absolute experts in designing processes in distributed ways. And when these guys are going to be able to get access to proper hardware, they're probably going to kick some serious ass. So thanks Amazon for basically opening distributed computing to an entire new generation of people.
What's your feeling about stuff like Hadoop and projects like that, where people are running those on top of EC2 and S3?
Excellent. The only thing is that the only reason why I've not used them is because I wanted to be able to learn more about the entire system. But obviously, if you're running Hadoop locally or technologies like, for example, Erlang or other distributed technologies, I know they have MPI images and stuff like that. Great, use the stuff you actually know best, but when it comes to actually getting cheap machines, especially machines which you run for specific tasks and then shut down and they basically stop costing you any money, there's no one can actually beat Amazon right now. Not even some. Because I believe they are more in the region of at least $1 per CPU per hour. So that's 10 times the price of it.
Sounds familiar.
Yeah.
Do you know of any research usage of
the more interesting people, they don't tend to blog about the kind of stuff they do as much as the others. But I've read some stuff just a few hours ago, actually. So it's basically a guy who's been helping people work on S3 and EC2 as a consultant, who says that there's a lot of data crunching happening for a lot of clever people. But I wouldn't go into much more details. And I'm not in a position to invent one right now on the spot. But have a look at aws.amazon.com and you have cases which they go through. Obviously, it's mostly people who are interested in getting some free publicity from Amazon. So you get a whole bunch of startups, but you probably get some interesting people who do some pretty cool stuff with them.
So there's no competition to what Amazon is trying to do. I mean, that ties into the question regarding commitment. Is that if they really are like the new monopoly in chip computing, and some just misses the boat because they keep insisting to ship hardware boxes.
Right now, there is no competition coming from big names. There are a few people who are actually starting hosting companies based on exactly the same principles, but they don't have the financial backing that Amazon has. They don't look half as serious. The good thing is that they're actually pretty clever in finding new uses and stuff like that and trying new things. So it's an entire industry that's gotten a pretty serious kick in the ass from Amazon and just going and inventing new things. So it's probably going to be pretty exciting in the next year also. I bet Amazon will not be the only one doing that kind of stuff in a year. People have to react.
At some day, the map and reduce guys will go on the market probably.
Yeah?
The map and reduce guys that you mentioned they will go to market at some day, probably.
I did not mention anything about MapReduce. That's a very specific Google term. And,
well, another question about what about failover handling? So did I get this right? They don't provide anything for you to support. So that's your task.
Yeah,
they have to make sure that when one of your machines crashes for whatever reason, you have to be in a position to just continue.
Yeah, you have to provide the cleverness. They only bring the tools, and it's simple tools, pretty reliable tools, but yeah, they're not magical tools either. You have to basically come up with very creative use for the tools.
Do they publish numbers, how much it gets used?
Yeah.
Do they give any assurances about the data you stored there? Would they be liable if they lost everything?
So you're talking about SLAs?
Yeah, for those prices, I know.
Yeah, that's exactly the point of view. They're saying if you want SLAs, well, yeah, you will get you to pay sell prices, and that's it.
So they'll probably save your data.
they distribute your data into the cloud. So if they have machines which
2 copies, 3 copies, you never know. This is fatal.
It's for them to know. And I wouldn't be surprised if it's pretty much in effect very similar to the Google file system, which people talk a lot about, but unless they work at Google, have not been able to use because it's not released. So it's the next best thing, I'd say. But don't expect an SLA for 10 cents per instance per hour.
So we better should keep a local copy of the data if we store something on S3.
Yeah.
If the data is valuable.
Yeah.
No.
Well, it's the case for everything, you know. Like you store it on a hard drive and suddenly there's a nuclear strike or something. It's the same thing.
So what about performance in the cloud itself? If you have some big data on a cloud machine and you want to store it into S3 or get it from S3,
they're actually
is it fast?
It's perceived by me as being extremely fast.
Okay.
They've started talking about some stuff along the lines of the fact that there are several data centers which are interconnected by pretty beefy lines, but they don't go into details. They've also mentioned the fact that when you do access some files from a specific data center, it comes closer and closer to you over time. And that's actually visible with your images. That's the reason why starting or booting up your first machine takes about 4 minutes, depending on the size of the data, or the size of the image. And then starting up next time is actually much faster. Usually in the region of 4 minutes, first time you boot up, and after you put it in, it's probably in the region of 1 minute. And that's included the Linux boot time. So you just go 60 seconds, you have a setup. Shut it down, it's instant.
Bye-bye data.
Yeah. Bye-bye data. Exactly. Yeah. So no more questions?
Thanks a lot to Opteros as well for hosting us today. Some people will stick around and move chairs, I guess. And we're going to Tom P.